Hello, my name is Marisa Lucarelli.
And I'm Alexis Guerin, and we are with the University of Toledo.
This research is in combination with our professor, Dr. Caroline Menezes, and is entitled Changes in Speech Articulator Movement in Parkinson's Disease Following a Boxing Exercise Routine, an Exploration of New Treatment Strategies.
To begin, our main question of this study asked whether non-combative boxing therapy has any effect on acoustic vowel space in the presence of Parkinson's disease. We measured the first and second format values in the controlled target vowels and determined the vowel space by examining the shape of the airway between the glottis and the lips, which relates to the first two format frequencies. Format 1, or F1, is the tongue height of the vowel tract. Format 2, or F2, is the horizontal placement of the tongue.
Our study relates to many past research studies which examine the effects of physical exercise on the brain. Previous findings by researchers such as Tanaka, Fisher, Vanillo, and Sasko all suggested that increasing motor movements positively influence brain activity associated with language. There's also a previous study that was conducted in our lab that examined the vowel space of subjects with Parkinson's disease and comparing them to healthy controls. These results showed that speakers with PD showed a reduced acoustic and articulatory vowel space. These PD speakers also showed more variability in their vowels while also producing vowels further back in the vocal tract. We seek to use this current study that we'll be presenting today to build off of these findings.
This study is a block design study which is conducted over a 2-day period. For example, subject 1 may first have their hand movements recorded, which is done by a fellow occupational therapist, and then they would move into a 30-minute boxing routine. After their boxing routine, we would measure their speech movements using EMA, the electromagnetic articulograph. Day 2, the same subject will come back and they will first measure their speech movements in EMA, and then they will move to their boxing routine. And then after their boxing routine, they will, the occupational therapist will record their hand movements. Both subject 1 and subject 2 will flip schedules so that they all have a pre and post speech recording.
Our study had 2 subjects, both male in their mid-60s, and they were both diagnosed with Parkinson's within the last 3 years. Both subjects also had right limb dominance, left side tremors, and are taking the drug Cinnamon.
Our stimulus consisted of 24 original utterances which were randomized, with 8 target words containing 3 different vowels, E, U, and A. So for example, one of our stimuluses will have our words within the initial stress, and some of the words consist of mami, mima, muma, and mamu. And then we'll have 4 words in the final stress, which will include mami, mima, muma, and mamu. These 2 utterances that are presented will be short and long, and the utterances will be repeated 5 times per subject.
These are some examples of utterances our subjects said. An example of the short utterance would be, Mommy will speak to Mima, and that would be initial stress. An example of a long utterance would be, Mamu and Muma, Mima will speak to me, and Mami, and that would be final stress. When we analyzed our data, we separated the results by subject. So for subject 1, we found that boxing reduced the vowel space for both stressed and unstressed vowels, with stressed vowels being more reduced. This was kind of not what we were expecting, but we'll examine this later after I show you the graphs of the vowel space. We also found that subject 1 had a displacement of the U vowel present in the post-boxing condition, which indicated higher F1 and lower F2 than typical speakers. And we thought that maybe that was because of more lip rounding to compensate for fatigue or lack of precision.
Similar to subject 1, subject 2 during the stressed vowels had a reduced vowel space in the pre-boxing condition. Following boxing, the stressed vowel space was 72% larger than the unstressed vowel.
These are 4 bar graphs showing stressed and unstressed vowels for both subject 1 and subject 2. So we observed that vowels that were most affected by the boxing were oo and ah, as there is more of a difference between the two. Generally, boxing increased the second format more across both first and second, or subject 1 and subject 2, with F1 showing more mixed results that were more variable and not consistent.
So this is subject 1's vowel space with unstressed vowel in the pre and post boxing. The blue here is pre-boxing and the orange is post-boxing. And here we see a 12.4 decrease in vowel space from pre to post-boxing. This is also subject 1's vowel space, and this is the stressed vowel space with pre and post-boxing. The blue here is the pre-boxing and the orange here is the post-boxing. And here we see a 92.4 decrease in area. We also see the oo here is has a higher F1 value than typical speakers in the post-boxing vowel space.
This is the vowel space for stressed vowels for subject 2. Here we see the green is the pre and the purple is the post. And this is a 44.8% increase in area, which is what we were kind of hoping for this study. Subject 2 was also able to maintain their vowel identity. For the unstressed vowels, however, we are back to the decrease. We see a 70.5% decrease in the area from pre to post boxing, but subject 2 is still able to maintain their vowel identity.
So in conclusion, although the subjects used different strategies, the boxing helped the subject differentiate between the stressed and unstressed vowels. Extraneous movements and Parkinson's disease might be the leading cause of the extended vowel space. However, perception experiments are needed to test this hypothesis.
We also would like to conduct further research analyzing the articulatory data to arrive at the articulatory vowel spaces for pre and post boxing. It would also be great with further research to have a more variety of subjects with a more variety of gender and severity of Parkinson's. So in conclusion, we found that boxing has an effect on vowel spaces in 2 ways, by either reducing the extraneous movements as in subject 1 or by increasing the phonological identity of the vowel as in subject 2.
And here are our references.
Thank you.